So in this one, you can see our matrix A is given. So here you can easily get it that it is orthonormal rows it is having. You can check easily. These are orthonormal rows. If you do the dot product of any two rows, then you will get 0. And if you find out the norm, then it will be equal to 1. Okay, same for columns you can check. 12, it will be a 6, and it will be minus 18. Okay, so this is 0. So these three rows and columns are, sorry, the column set is forming an orthonormal set, and as well as the row set is forming orthonormal. So for
So
orthogonal, yeah,
this is an orthogonal matrix, right, sir?
what?
This is an orthogonal matrix, right, sir?
Yeah, yeah. So A transpose will be equal to identity, or in easy way, if I say that A transpose will be equal to A inverse. So you don't have to calculate this A inverse by finding out the adjoint and then dividing it by uh, determinant of A. You can directly compute this A transpose. Okay, so in this one you can see only this option is the A transpose that is matching. 236 here, 263 here, 263 here, and 236 here, and 2727 will remain same, and here it will be minus 3 by 7 and minus 6 by 7. Minus 3 by 7, minus 6 by 7. So this option is correct. Okay. After this,
Okay, sir.
we have this one. So you know that when you have a transformation from R3, it is given linear transformation, and we are making some matrices by using beta 1 for both domain and codomain firstly, and then beta 2 for domain and codomain. So you know that it is the matrix A and it is the matrix B, and when
Yep.
we represent beta 2 in terms of beta 1, so we will get matrix P, and when we represent beta 1 in terms of beta 2, so we will get our matrix Q or P inverse.
Similar matrices.
So A and B are similar matrices, right? Yeah. P inverse AP. So if these two are similar, so their rank is going to be similar, trace is going to be similar, sorry, same, and the determinant will be also same. Okay, so that's why these three options are correct. These two are not correct. Can you tell me that why these are not correct?
It depends upon the basis
Yeah,
beta 1 and beta 2.
exactly. You can take example like this. Uh, Suppose you are having two matrices. First is your, this matrix 0, 1, 0, 0, and another is 0, 0, 0, 1.
My
So
doubt is why they are saying ki they are similar. We are talking about the similar matrix or not.
it is a general case in when we were discussing the topic. So it was a special case that it will always be similar if you are using two bases. It is a fact. That's all. Just like that, if you use different bases for uh, if you use beta 1 here and gamma beta 1 and gamma 1 here and beta 2 gamma 2, then when you represent it like this, so you will get equivalent matrix.
Equivalent matrices.
Okay, but if the bases are same both side, then you can say that you will get uh, a similar matrix. So here if you try, so as we know that for similar, B is equal to P inverse AP. So it is easier to find solution for this.
Sir, sir,
Yeah,
in case of this, since you told that these matrices are similar, so in case of similar matrices, sir, won't the column space like because the column space will be R3 only, right, sir?
yeah. In this case, okay, if you want a matrix in R3, so let's say I was just giving a general example. Okay, let's take it in R3. Okay,
Mhm. Okay.
suppose this is my matrix.
Okay.
Okay,
So zero
and
zero zero or 001. Okay.
it will be okay. And the other matrix I am taking is 1, 0, 1, 0, 0, 0, 0. Okay. So if I multiply it by P, suppose my P is nothing but A, B, C, and D, E, F, and G, H, I. Okay. So it should be equal to AP. So A multiplied by P. P is nothing but A, B, C, and D, E, F, and then G, H, I. Okay. When you do the multiplication, you will get A here and B next element. The third element will be 0, right?
So one row you are entirely taking as zero, sir.
Yeah, yeah. I am just taking because when you look at this, so its column space, you can easily figure out that its column space is different than this one, right? It is observable easily. So that's why I took this example. Okay. And mostly elements I took 0 so that it will be easier to find out this thing. So if I do this, so I will get a D E 0 here and G H 0 here. Okay, this is my left hand side matrix and I want to equate it with the right hand side matrix. So what would that be? A, B, C, and this one will be 0, 0, 0, right? 0, 0, 0. Yeah. Then
GHI.
G, H, I. Yeah. Okay. So if you compare these two, so you will get A is equal to A, B is equal to B, and C is equal to 0 you got. D is equal to 0, okay. And E is equal to 0 and I is equal to 0. 4 variables you got that these are zeros. Okay. Next thing we have to check that the determinant of this is our P, right? So I can write in place of C, D, E, and I. All other are 3 variables. So I can write it is 0, 0, 0, 0. One extra thing I need to check that its determinant should be non-zero.
Non-zero.
Okay, so if I find out determinant of this, so it will be minus F, A, B, G, H. So I have to take values of these variables such that its determinant is non-zero. So I can put easy values. B is equal to 0 and G is equal to 0. Okay, B and G 0 and A equals 1, H is equal to 1 and F is equal to 1. You can see that I got a matrix whose determinant is non-zero and I can write it like this. It will satisfy this condition. Okay. My matrix will be A, B, H if I put 1 here, 1 here, 1 here, 1 here, and 1 here. Sorry, this is 0. G is 0. Okay. G is 0 and it is 1, 1, 1. So if you now multiply these two matrices and here, so you will get, or if you find out the inverse of this, then you can find out and compare this. So you will get that these two are similar. Okay. And if these two are similar, you can see here that column space of this is not matching with column space of this. Its column space look like X, Y, 0, and its column space look like X, 0, Z. So these two are not.
Sir, but this one is looking like this because you have, because here in the first case, like our last row is 0, right? And in the second case,
second row is 0.
Sir, but what if, like, we have some other basis, where, like, we have all the 3 rows. Say, for example, like, it's not a null. The one row is not at all 0. Like, that's what I mean.
Okay, then it is also possible. In that case, it will be there. Maybe in some example you will get exactly same. Suppose your rank is full, rank is 3. Okay, so in that case you can see all 3 variables, and you know that similar matrix have same rank. Okay, so if its rank is 3, its rank is 3. So in that case you can see column space is same. It will be whole R3, right?
But this will not be the case always.
So it is not always the case. So that's why we are considering some of the cases. So always it is not going to be same and same for the other thing. It is not always going to be different. In some cases it will be equal, and in some cases it will not be. So it is saying for always if you have to find out. So general thing it is taking. So we can't consider these two options because they are not entirely correct or wrong.
Okay, sir.
Okay. That's the part.
Yes.
After that we have this. So it is saying that which of the following are equivalent to A. So I said that 2 methods are there to find out that they are equivalent or not. Check rank.
Rank.
Or check the elementary row and column operation if you are able to derive the other using EC or ER. So you can see here its rank is 2, I think.
2. Yes.
Divide by 2 or simply add twice of this. So it will be 0 and it will be -1 and it will be 8. And upper one will be 1, 0, minus 3 by 2. In this one, you can see that rank is
2.
In this one, you can see rank is 2. In this one, rank is 1.
Yes.
Exactly multiple of the first one. In next one, you can see the rank is again 2.
Yes.
And in this one, rank is again 2. So that's why these 3 options are correct. Okay. After that, we have this. A matrix is given here. So A is equivalent to B, then they have same rank, trace, and determinant. It is for similarity, not for equivalency, right?
Yes, sir.
Because the determinant is not always findable in that case. But in this one, A is given as like this, so it is not considered always. I said that even if it is a square
Sir,
matrix, still
sir,
we
how
will
many,
get.
sorry, sir,
Yeah.
sorry to interrupt, sir. How many options were correct in the previous one?
In previous one, three
Three.
options were correct.
Okay.
Second one is wrong only because it has rank 1.
Yeah, it's okay. Got it.
So next one, you can see that this rank, trace, and determinant are same when they are similar, not equivalent. Okay. In next one, it is given B is a 2 by 2 matrix with same rank, trace, and determinant. Then they are similar. No, it is not. Even after these
No.
things are same, still we can't say that they are similar. I gave already an example in the lecture then in which I was explaining that topic. Next is this one. B is a matrix belonging to 2 by 2, okay, and A is this one, then A and B are equivalent. Okay, you can see if A is equal to 0 minus 1, 5, 0. So one thing you can consider here that it is an invertible matrix, right?
Yes, determinant is
Yes,
not
sir.
0.
Invertible. Yeah. If you multiply this matrix to B, then if you find rank of this, so it will be same as rank of A, right?
Yes, sir.
Means rank of A and rank of B will remain same even after this multiplication.
Yes.
Okay. So if these ranks are same, so they are equivalent, right? So, or one thing you can say that A can be written as this matrix, suppose it is Q and B, and you can multiply it by I.
Sir,
Yeah.
how we get that? Like, there is saying like equivalence, invertibility is a check, but here rank of A and rank of B. How can we just imagine a B where B is not given anything?
Okay. Suppose your B is some matrix. Okay. Any matrix of any rank or anything. Okay. So if I multiply this by some matrix M whose determinant is non-zero, so rank of MB will depend upon
Less than equal
rank
to.
of B, right? And here is A. So if I say that it is equal to rank of A, got it?
Sir,
Rank
how?
of
Sir, it can
Yeah.
be at most rank of B, right, sir?
Let me tell you one more thing. Not at most, it will be equal to this. Suppose it is given already that this A is equal to this. So if I find out rank on both sides, so it will be equal to rank of A is equal to rank of, suppose this is my M matrix. Okay, rank of, or you can say that it is P or Q, whatever. Q, B. It is invertible, so it will entirely depend upon the this function's rank will entirely depend upon the rank of B. So from here, I got rank of A is equal to rank of B. And if these two are equal rank, then they are equivalent.
Sir,
any
we
invertible
can
matrix.
multiply this inverse of this matrix to A and find the B from this equation, right, sir? From that, we can calculate the rank of B. Will that work,
But
sir?
you are saying that you will
We
take
can
this.
multiply.
Yeah,
Yeah,
you
we
can
can multiply the inverse of 0 minus 150 to A so that we can get B. From that,
yeah,
we
yeah,
can get the
exactly.
rank of B.
Yeah, you can continue with that. That's also fine. But here B is not you have to find out. You just have to check that they are equivalent or not. So if
Yeah,
rank is
by checking
same,
the rank.
yeah, rank is same, then it is equivalent. Otherwise, you can go. Yeah, that's also fine. If you want to find out by multiplying it by inverse of this and then going on finding out B and then checking that they are equivalent or not, that's exactly correct.
So
Yeah.
it's the same thing, no? You did.
Yeah. In this one, no, I didn't find out this inverse of this matrix. I just
But
simply
we
found that.
already know that the rank would be less that of B, no, sir?
Sorry.
Rank of that matrix multiplied by B would be rank of B, no? We know that. So
Yeah, rank
we
of
end
this
up
one is
doing the same thing just by, just we are adding some extra step by that, by multiplying that inverse.
Sorry, I didn't get once again. Please tell me.
So what I said is, rather than going this way, what we did was we multiplied the inverse both the side.
Yeah.
We know that the inverse rank of inverse would be same as rank of that matrix itself.
Yeah.
So we
Full
ended up
rank
doing the
only
same thing, na, sir?
only. Yeah, yeah. This is exactly same thing, nothing else, because we know that if a matrix is invertible, then both rank will be full. If it is Q and Q inverse here, so these two will be of full rank.
What the last option says.
So uh, A is equivalent to 2 by any 2 by 2 orthogonal matrix. So if you know that 2 by 2 it is and orthogonal. So orthogonal matrices are
Full rank.
full rank. Okay, or you can say that they have linearly independent rows. And if all rows, if 2 by 2 matrix I am having, suppose not this one. So uh,
Sir, in this orthogonal matrix, we don't have to take care of about the orthonormal thing.
no, nothing else. You just have to think that rank should be same for equivalency. So it has full rank. Okay, rank is 2. So
Yeah.
if you take a 2 by 2, any 2 by 2 orthogonal matrix, its rank will be 2. So
How
that's
we
all.
imagine A as equivalent, like A's rank and orthogonal matrix. Orthogonal has a full rank, but how
Yeah.
we imagine A is also a full rank matrix, even though there can be zeros in it.
E is given.
A is given, na?
Okay.
Find the rank of A.
Oh, that's given.
Okay. So is that clear now?
Excuse me, sir. Could you
Yeah.
please repeat once again the third option? Why the
Third.
rank of the given matrix and B is same?
Okay. There was one fact that states that if you multiply any matrix, if you have a matrix B, suppose, and you multiply it by M, okay, then you find out the rank. And this M is invertible. Okay, means determinant of M is non-zero. So then this rank is also equal to rank of B. This was the fact. So I applied it here. I find out A is equal to this is given. So I said that I will find out rank both side, because if these two matrices are equal, A and this matrix multiplied by, suppose this is Q. So A is QB given. Okay. So their rank will be same if they are equal. Okay. So rank of A will be equal to rank of QB, right? And Q is given here. You can see it is its determinant is non-zero. So its rank will be equal to rank of B. Is that clear?
Okay, sir. So it's a property that if in multiplication
If
the
you have,
rank if the one of the matrix is invertible.
yeah, so it will depend upon the other matrix rank.
Okay.
Okay.
Okay. Okay.
So let's move on. Uh, Anyone else having any other query related to this question?
No, sir.
Next is find the maximum nullity of a 3 by 4 matrix. So you know that rank and nullity depends upon the
Number
columns,
of columns.
number of columns.
Number of
Yes,
columns.
yes.
So 4 columns are there. So if you want
Yes,
maximum
sir.
nullity, it will for 0 matrix. Okay, you can consider a 0 matrix. In this case, you can see no column has pivot. So nullity will be 4.
Rank 0, nullity 4.
In that case, 4. Next is this one. A and B are given, and it is given that they are similar matrix to A, and B11 is given like this. Okay. So A is your this one, and B is this. So B is 1/1th term. This one is given. Asking this one. So you know that the traces are
Trace is
same.
same.
Yes, sir.
So
Trace,
what will be the
trace.
trace of A? It is 4 trace of A, 5
7
minus,
minus x is equal to 4.
suppose it is X, so it will be equal to 7 plus 7. And from here, X value is there.
Yes.
So here. After that, another matrix A is given here in this one. Yes, Mayu?
Uh,
You can mute
yeah,
yourself.
just yeah, I just have clicked and then
So in this one, you have to find out, okay, vector is given, this vector is given, it is inside the null space. Okay, so we have to find out alpha minus beta value. So A is here. So if I find out any vector that belongs to null space, so it will be equal
Ax
to
is
if I
equal to
put that
0.
in also equal 0. So the vector I am given is alpha beta, and what was that? 2 and minus 2 and minus 1. So it is going to be equal to this 0 vector. 3, 3 or 4. 3 will be there, right?
Yes, sir.
So if I do the multiplication on the left hand side, so I will get 3 equations. Or simply you can reduce it. Firstly, solving before solving this, you can reduce it. So it will be like if I do R2 minus R1, so what I will get 1 1 2 0. Here I will get 0 minus 1 and minus 1 minus 2 0 1 1 2. If I multiply R, if I do R3 plus R2, so it will become 0, right? If I'm adding
Yes,
R2,
sir.
it will be 0 0 0 0, and I multiply R2 by minus 1, so it will be plus 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 1. So I got this equation. So if I find out the solutions now, alpha beta 2 minus 1, so it will be equal to 0 vector 0 0 0. So let's do it. So it will be alpha plus beta plus 2 2s are 4 is equal to 0. In next one, if I do the multiplication, it will be equal to beta plus 2 minus 2 is equal to 0. So from this equation, I got beta value as 0. If I put beta here, so I got alpha value as minus 4. Okay. I have to find out value of alpha minus beta. So it will be minus 4 minus 0, that is minus 4. So here it is. Okay.
Yes, sir.
Next is nullity of matrix A. So A matrix is here and its reduced form is here. So what is the nullity? Two columns have pivot and two are
2
without
are null.
pivot.
Yes, 2
Nullity
is
will be,
null.
okay, here is the nullity.
Sir, hello.
Yeah,
So is it true that dimension of null is equal to nullity?
yeah, exactly.
So, but here our dimension is one, no? Right?
Where is the dimension one?
Dimension of null space. What is your null space, sir?
In this one, null space is going to be null space we didn't find. We have to find out by putting here x, y, z, and w, and then calculating the equations. We will get. You can directly check the nullity, that number of columns without pivot.
See, I got that, sir. Nullity is zero, two. Sorry,
Okay.
but I want to find out null space.
Okay. So null space you can find from this directly. Your matrix is in reduced form 1 1 2 0
Okay, okay, yes, sir.
and 0 1 1 2, and last row is entirely 0. So if you multiply it by any x, y, z, and w, four variables. So if you do the multiplication, you will get
But
x
so in
plus.
question, the value of g and w is given, no? 2 and minus 1.
This is a vector, complete vector. It is given alpha and beta value. We have to find out based on these two. Two values are given because these are free variables. So that's why it firstly constrained them, give them fixed value because these two value can define these two.
Okay.
Okay, so that's why two values we need to find out the all four values of the
Yes, sir.
solution.
Yes.
Okay, so that's why it is these two are forming the null. It is or nullity. They will go. Okay.
Okay, sir. Got it.
In next one, we have to we are given a linear transformation determined by this, this, and this is given. Okay. We are given a transformation x, y, z, and we are given, okay, not given. We have to find out the transformation. General form we need to convert. Okay, we are given some basis and we have to find out the general form. So transformation of 1 0 0 given, 0 0 1 given, and 1 1 0 given. Okay. So I can find out transformation of 0 1 0. So it will be equal to transformation of 110 minus 011 transformation. Okay. So 110 transformation is given as minus 231. And if I subtract 104 out of it, so what I will get? Minus 3, 3, and minus 3. Okay. So if I form, if I want to form, find out the
011 is not given, right?
what? General form is not given. Yeah, we have to find out x by
So
z.
it
So
is
I can
P of
write
100.
what?
Sir, here you write
The
1 comma
first
0.
step, first step.
First step.
Yes, sir. Right side.
This one. Oh, sorry, I wrote
Yes, sir.
wrong. It should be 100, right? I
Yes.
forgot. Yeah, missed it. So it is here. So I can find out transformation of x, y, z by writing it like this: x times 100 and plus y times 010 plus z times 00. Basically, I just calculated standard basis in order to get this because now it becomes easier. Otherwise, I can directly move with this, and then I have to find out that how can I define it as a linear combination of these three vectors: this one, and this. These x, y, z. But now it is easier. So I can say that it will be x times transformation of this 100, that is 104, 104 plus y times the transformation of 010.
Minus 3, 3.
Yeah, minus 3, 3
Minus 3.
plus z times 001,
1 minus
1 minus.
1.
So if you add these three, so you will get your first equation as x minus 3y plus z. Next will be 3y minus z, and third one will be 4x minus 3y plus z. Is that okay?
Yes, sir.
Now let's check. Okay. So x minus 3y, x minus 3y plus z. Okay. 3y minus z, 4x minus 3y plus z. Okay. So this one is correct. Okay. Next, it is given 1, 1 and on 2 we have to check. Okay. So yeah, this is okay. So what I can do, I can represent it as matrix, and then I can find out, or general form I am having, so I can form the equations out of it by equating it equal to 0.
Yes,
0
sir.
vector. Okay.
T of
Go
0,
with the
0, 0.
matrix.
What?
Go with
T of
matrix.
0, 0, 0.
Matrix. Okay. So let's say with matrix I can go 104. So I can write 104 and then minus 3, 3, minus 3, and then 1, minus 1, 1. You can easily see that this column is dependent on this. Easily observable. Okay, or if you want to go, then you can say that R3 minus 4 times R1. So what I will get here? 1 minus 3, 1, and 0, 0, 3 minus 1. And here I will get 4 times of this one minus 12 and plus 12. So it will be 9. And 4 times of this one will be minus 4. And if I add here, so it will be equal to minus 3. So now what I can say that R3 minus 3 times of R2. So if I do, so it will be 1 minus 3, 1, 0, 3 minus 1, and it will be 0, 0, 0. So now I can multiply my R2, sorry, divide by 3. So it will be 1 and it will be minus 1 by 3. So you can see that two columns are having pivot, third is without pivot. So in this case, nullity is equal to 1. Okay, now let's go here. R3 to R3 we have to define. So I had 3 dimension here, 1 gone for nullity, 2 gone for range space, and this is having 3 codomain. Okay, so its a nullity is more than 0, so it is not 1, 1.
1 minus
Okay, and these two are not completely filling this 3 dimensions, so it is not onto.
1, 2.
So neither 1 1 and nor onto is correct.
Sir, one question I have.
Yeah.
Could you please scroll up a bit?
Sorry, what?
Scroll up, sir. Could you please
Okay.
scroll up a bit? Yeah,
Yeah.
that's so. Yeah, here. So is it always the case that we write these values 104 on in column wise, or if you write it in row wise, it is any difference? Make any difference or not?
Uh, this is a matrix that I formed.
Yeah, yeah.
Okay, when we form the matrix out of it, suppose here we have R3 to R3, so it is not making as much change like this, but it will make changes to the range space and that all.
Okay.
It will make a change
But
here.
sir, in
If you,
some cases, I saw many TAs write this in row wise, and some of them write it in column wise. So that's why I have
no, no,
confusion.
no, when you are forming a transformation matrix, okay, when you are forming transformation matrix, then you have to write down like this.
I mean, we have to prefer column wise, right?
Yeah, prefer column wise. It is good. Or if you write it row wise, then you are only calculating this nullity. Okay, so then it is not going to make any change. But suppose you want to find out the range space and null space, then it will cause a problem in that time.
Column method preserves the basis vectors.
Yeah.
Yes, sir.
Okay, sir, got it.
So then it will make changes. For nullity and rank, it is not going to make any change because row rank and column rank are same, right? Uh,
Yes, it's rolling.
for rank, maybe it can make change. Still, it can make change. If you are finding rank, then still it can make change.
So basically, we have to prefer write these values as column wise.
Just a minute. Let me.
Okay, sir. Thank you then. Arre, why you left the meeting?
Okay. So this is I got it's in neither 1 1 and nor on 2. Okay. So after it, I have a question here in this one. Transformation of x, y, and z are given like this, and we have to find out for all. Okay. Then in the question, find the value of k for which nullity of this transformation is 2. Okay, I have to find out the nullity of this transformation. So I still have methods like I can equate it to 0, comma 0, and then I can find out the null space in that case. Okay. Or other thing what I can do, uh, other thing what can I do? I can say that I can make the matrix out of it, and then I can find out the nullity as in above I did. So let's do it by that.
So using standard basis.
Yeah, standard basis we will take because the uh, rank and what do we say? Rank will be same and nullity will be same in both cases. Rank and nullity will be same. Okay. So what I can say that if it is, so let's make the matrix 1 0 0. Suppose I am taking. So if I take x value 1 and all other variables are 0, so it is 1 and these will be 0. So I got my first vector as
One,
1,
one, two.
2. Okay. If I put 0 1 0, so what I will get here?
Minus 3, minus 2. Oh, sorry, plus 2.
Minus 3 for y and here k.
K.
In third one, if I put 0 0 1 0 0 1, so z value is 1, so it will be
Minus
minus
k plus
k
1.
plus 1.
10.
Okay, and this one will be 10. So if its nullity is 2, means its last two columns will be, or not last two, I can say that out of these three columns, two columns are dependent on one. Means one column will be linearly independent. Suppose this is linearly independent because it is first, so it will have the pivot. I have to make the below one 0. So means I can say that this vector is a multiple of this and this is also a multiple of this. Okay, so if this vector minus 3 2 is a multiple of 1 by 2, so sorry, not 1 by 2, 1 2. So what I can say that if I multiply it by minus 3 times, so I will get my first value is equal, right? Or I can say that it will be equal to p times this. So if I multiply it with p, so I will get p 2p. So if I compare these two values, so p value is minus 3, right? From first component comparison. And
Sir,
then I
why
can,
are we going for with 1 and 2, sir? Shouldn't it be k plus 1 and 10?
we can also go with this. We have to find out, listen, nullity is 2. So only one linearly independent column is
Correct,
there.
correct, sir. Yes, sir.
Okay. So all these three columns are multiple of one another.
Okay, okay, okay. Got it, got
Okay.
it.
Or it
Yes,
might,
yes.
okay. Because no one is a zero column, you can see that this is not a zero vector, not neither this and this. It is also
How
possible that
P,
some of them are zero vector.
how P came in that?
What?
How P came in this equation
I
minus
said,
sec 1k is equal to
okay, okay. I said that it is a scalar multiple of this, right? So I said that if I multiply p times this, so I will get this. If two vectors are linearly independent, then you can say that alpha times v1 is equal to beta times, sorry, plus beta times v2 is equal to 0, right? I can say that alpha times v1
yes.
will be equal to minus beta times v2. I can say that v1 is equal to if alpha is non-zero value. So I can say that beta by alpha v2. So you can see that this minus beta by alpha, I have to put some constant. So I can put any constant. So I put p.
So we
Means,
can go for row multiplication also, no, sir?
yeah, we can also go with that. That is also okay. You can say that this the second row is twice of this.
Yes, sir.
It will be minus 6 directly, and
Yes,
it will be minus k plus 1 should be equal to 5. So
yes,
from here, if you find k value, so it will be minus 6.
yes, sir.
So both equations are giving the same value. So I can say that k's value is minus 6. Is that clear?
Yes, sir.
Anyone still facing any issue? Then they can tell me. Okay. After that, we have to find out which of the following will be in the range of t. So same way I said that we can't write columns as rows because this column is going to have only pivot. So this column I will consider it as my any column you can consider as
Basis.
your range. Okay, but mostly we continue with the pivot. Pivot columns you are into it for till now you have used that method, so use that. So 1 2 we will take. So 1 2 is there. So it is in the range. Now you are saying that why is it? Because it's scalar multiple. All the
Yes, sir.
vectors in this form 2x, sorry, x comma 2x will be in the range space. Okay. So if I put x value minus 1, so I will get this vector. Other two are not multiple of this, so they are not inside the range. Okay.
Yes,
Let's
sir.
continue forward. So here we are given T be an orthogonal transformation. So with usual inner product. Okay. T is some orthogonal transformation. What are orthogonal transformation? If I do TB and T use inner product, usual inner product means dot product. So if I do dot product of these two, so it should be equal to in that case U dot B. Usual given, otherwise we will use the manually defined inner product. Okay. So if the dot product of these two is equal to DOB, so I have to find norm of this. So you know that norm is nothing but
Done.
any vector. Suppose your vector is a transformation of this. So you can say that transformation of 403 dot product with transformation of 403. Okay, so it will be same as transformation of 403. 403 will be equal to uh, 403's dot product with 403 because it is an orthogonal transformation. So if you do the dot product, you will get the value 5. 4 square 16, 3 square 9. So 16 plus 9, 25, and its root will be 5. Okay. So the value is 5. Answer. Okay. After that, suppose Q is the matrix representation of T. T is orthogonal, so you know that Q will be orthogonal matrix. Okay, we have to find out determinant of Q square. So I said that we know that orthogonal matrix it will be, so Q
A into
transpose
A
is
transpose is A into A inverse.
yeah. So you can say that determinant of this one will be equal to determinant of this. So QQ transpose will be equal to determinant of Q dot determinant of Q, because Q transpose determinant is same as Q. So I am writing determinant of Q. So it will be equal to determinant of identity matrix. It is 1. And this will be determinant of Q square. That is 1. So determinant of Q is basically nothing but plus or minus 1. Any one value. Okay. I have to find determinant of Q square. So I can write it as determinant of Q into Q. Or I can say that it will be equal to determinant of Q times determinant of Q. Okay. So it will be equal to determinant of Q square. So from here you can directly put the value 1. Okay.
Yes.
Next is this one. You are given two vectors. You have to find the angle. I think it is quite easy to find out.
Direct formula.
Yeah. Transformations are given. T of this and T of this you have to use, but you know that you have to find out if you want to find out angle between A and B. So just A dot B divided by A dot A,
A mod B.
B dot,
No,
No, okay.
and it's a
cos inverse.
square root, I think, right? This is, it is equal to cos theta. Okay, so A dot B if I do here, so it will be 1 times 1, 1 minus 2 plus 1 divided by square root of 1 plus
3,
1. Okay. And here you will have 1 plus 4 plus 1.
6.
So it will be equal to 0. We are getting in the numerator 0.
Yes.
So it's 0, cos theta is 0 at 90 degree or
Yes.
pi by 2 radian. Okay, or 90 degree. So whichever is there, pi by 2 is there, so it is correct. After that, we are given two vectors u1 and u2, and w is given as span of these two vectors. Okay. So ABC is the projection of u2 on u1. Projection we need to find out. I said that if you want to find out u2's or any vector b's projection on A, so you can say that b dot A divided by A dot A times A. If you do the dot product of these two, you will get 1 plus 1 divided by A dot A on which direction? U1 direction you have to find out. So its dot product with itself will give you 2. Okay, and then multiply it by A vector. So A vector is 1, 0, 1. So you got here it is 1, 0, 1. You have to find out A plus B plus C. It is ABC. So A value is 1, B value is 0, and C value is 1. So their sum is 2. Okay. After that, you are given u1, okay, v1 and v2 be orthonormal set of vectors given from, okay, we formed uh, orthonormal vectors out of these two vectors that were given earlier using Gram-Schmidt method. So we have to find out them. So what I can say that firstly I will divide my u1 by its norm to get my v1 directly. So if I divide it by its norm, so it will be 1 by root 2, 0, 1 by root. Norm is root 2. You can calculate because here we did dot product, so I got 2. So I have to put square root to get the norm. Okay. After that,
Yes, sir.
you can write u2 minus u2's projection on v1. It's v1. So it will be equal to w2. And if you divide w2 by its norm, so you will get your v2. Okay. So let's first get w2, u2 minus that one. So 1, 1, 1, and its projection on this one. Okay, u2's projection on u1. So we find out the projection, it was 101, right? So if I subtract 101 out of it, so I will get 0, 1, 0. Okay, if I divide it by its norm, so it will be same vector this, because its norm is 1. So this is my v2. v1 is this one, v2 is this one, or I can rewrite this as 1 by root 2 outside and 101. Okay, 1 by root 2 outside, 101 and 010. This one.
Sir, excuse me, sir.
Yeah.
Sir, could you please explain Gram-Schmidt rule process?
Okay. Suppose you have three vectors or some vectors here, u1, u2, and u3. You want to convert them to a to an orthonormal basis. Orthonormal. Okay. So you can say that these orthonormals are v1, v2, and v3. Okay. So how can you go from u1 to v1? So simply first vector if you are taking, so u1 divided by its norm.
So it is
You will,
also the property, right? If u1 and u2 and u3 are orthogonal, then we have to transform into orthonormal. Then we
yeah,
do
then directly
the
divide by norm. But here comes one complexity that they are not orthogonal. So now you have to remove the projections as well. So first projection you don't have to remove because it is its projection on itself is it's same this vector. Next, what you need to do, u2, you want to convert this to v2. So firstly, we have to convert it into the w2. W2 is orthogonal vector. Okay, it is a or it is a middle step of this. So u2 minus u2's projection on v1. You will get now w2.
u2 minus u2 projections on v1, right?
V1 we find out, yeah. So we got this W2, now divide it by its norm and you will get your V2.
Okay, okay.
Okay. Now if you want to find U3, so you have to subtract U3's projection on V1, then subtract U3's projection on V2, and so whatever you got is W3 now. And simple, the next step is same, that divided by its norm. So it will be V3. So what you have to do, each time you have to take a vector, remove its projection from the previously found vectors. V1 found, V2 found till now. Now we have found V3 as well. So what now if I have U4 here, so I have to remove U4's projection on V1, then remove U4 projection on V2, then U4 projection on V3. So now I will get W4. And if I divide it by its norm, so I will get my V4. Okay?
Okay, sir, got it. So just freeze your screen, sir. Could you please scroll up a bit? Yes, sir. That's just wait a second, sir.
Okay.
Sir, last time you gave another method, sir, which was much simpler by finding the orthogonal vector with respect to that V1. So we do not have to proceed with this the other steps.
Okay,
So
oh, that was specific to question. Okay, if you have to follow this Gram-Schmidt, then you have to follow it if it is given in question. But if you have a choices, then you can use that. That's also okay.
so can we end up having the same answers, or is it possible that will get a different answer?
It depends. We will get same answer. Most commonly, we will get the same answers.
Yeah,
But
in the exam I got the same answer.
yeah, so that's fine. You just want a perpendicular vector, then you can simply do the dot product and then you can equate it.
Yes, sir.
But keep that thing in mind. Here, two vectors we need to find out only. So in that case, it will not get changed. But in R3, if you are working, okay, and you have a vector here, and you want to find out its orthogonal vectors. So it has many vectors that are orthogonal. So it depends on the second vector that what was that given if you are
Okay.
using this Gram-Schmidt
And
method.
it worked in this case because we needed only two.
Yeah. So it's not always going to work. So, but this Gram-Schmidt method you can follow. It is lengthy, but it will give you the same answer. Okay, always it will give you the correct ones. But if you have choices in question, it is given that any vector you can take, so you can simply apply that method because it was easier to apply.
Yes.
So let's continue. Next is we are given, we have to find W. Okay, W is here, you can see. So W is span of these two. Okay, so simply I can say that x times my first vector 101 plus y times my second vector 111. So it will be in the span of this. So it will be x plus y, y, and x. Okay, in this way. So what I have to find out here. So my first value was x plus y, or I can say that alpha and beta I am taking. So it will be alpha plus beta, right? Instead of x and y, I am taking alpha and beta. So it will be beta and it will be alpha. it will be beta, and it will be alpha. So if I compare it with x,
The
y,
last value for both were 1, no, sir? Alpha.
yeah, yeah, both were 1. So it will be x plus z, right?
Yes, sir.
Sorry, x plus
X plus y.
y. So it will be alpha plus beta, right? So from here I got, in place of beta I can put y, means y value is beta, okay, or beta is equal to y. And if I put y here, so I got alpha value as z minus y, third equation, okay.
Yes, sir.
Or from first one I got alpha value is also equal to z minus x, okay. Z minus x or x minus y, it is x minus y. So alpha value are same. So if I equate now these two values, so what I will get, z minus y is equal to x minus y. From here I got x
X
is
is equal
equal
to
to
Z.
z. So this is my equation of W. Okay. All vectors in this form where x is equal to z, so will be inside my W. Okay. So let's move on. Or you can say that you know that W I need to find out. Another method I am telling that W perpendicular will be a null space of W, right?
Yes, sir.
Okay. So I have these two vectors. Okay. So if I find out any vector perpendicular to both of them, so you can continue from here where it was. These two vectors are there. So if I find out any vector perpendicular to both of them, suppose my vector is x, y, z. So if I do dot product with this one, so I will get x plus z equals 0. And from here, I got x plus y plus z is equal to 0. So from here, you know that x plus z is 0. So you can put x plus z is 0. So you will get y is
Okay.
equal to 0. Okay. So this equation and this one. So if
Same.
you have a vector x, y, z, so you can rewrite it as z value, you can write minus x and 0. So this will be inside your, this
Null
will be
space.
inside null space. Okay. So it is a null space. That's all. But what do we have to find out? We have to find out x equals 0. Okay. So you can continue with this. If because W perpendicular we don't have to find out, you can do this line. That's okay. Yeah, that's okay. Or you can check the null space of this. What is going to be the null space of this? This is going to be the same, that one. Null space of this, you can calculate x minus z is equal to 0. So from here you got x is equal to z. And if you put z value 1, so 1. Or simply
One
you will
zero
continue with this. It is
one.
because it is a little bit confusing. So let's solve. Let's leave it. You can continue with this one. That's okay. Because W perpendicular we don't have to find out. So why do you have to go like this? It might give you some other values as well. So let's leave it. That is okay. Okay, because W perpendicular and null space are not same in this case. Okay, let's see. Next is this one. ABC be a vector, okay, obtained by projecting 1, 2, 3 on W. So if I project 1, 2, 3 on W, so simple, I have orthonormal basis here. I can simply do the projection here. So I want 1, 2, 3 projection. So let's find out 1, 2, 3 projection on 1 by root 2, 0, 1 by root 2. So I do dot product between these two and then multiply by 1 by root 2, 0, 1 by root 2. So if I do this, so I will get 3 by 3 plus 1, 4 by root 2. And if I multiply it by this, so I will get 2, 0, 2. Okay, it's projection on this vector. And if I do 1, 2, 3's projection on the other one, 0, 1, 0. So I have to do the dot product here and then multiply by 0, 1, 0. Okay, so you will get
0 to
2,
0.
0, 2, 0. So if you add these two vectors, you will get 2, 2, 2. This is the projection. Okay,
Yes.
A, B, and C. So if you add these three values, so you will get 6.
6.
Okay. After that, you have to find out a affine subspace corresponding to W. So it is your W, right? So if I put it in this value in here, so what I can say that x is x comma y comma x. This is your W, x y x. Okay. So I said that if you want an affine subspace, so if you remove the constant part, so whatever you are going to be left, it is your subspace. So here you can see if you remove this constant part, so what you can say that x, y, x you will get.
So that answer is very confusing, sir. Normally, what we do is we write an equation, and on the right side we equate to some value other than 0.
Sorry, where?
Sir, we had that equation, na, x equal to y. So I wrote x minus y equal to 0, and then I tried to search for any other uh, value in that answer. So we have this, na, x equal to z.
Yeah, we had
So
this.
I wrote it as x minus z equal to 0.
Okay, x minus z equals 0.
Then I tried to search for any equation of form x minus z is equal to k, but it was not there. So I couldn't answer that.
So that's all. What you can do, other thing, what you can try, you can write this one. You can say that it will be x, y, x plus 2, right? So I can rewrite it as x, y, x plus 0, 0, 2. This is my translatory vector, and this is the,
Yes, yes, yes. So this is a better approach.
in this way you can continue. Okay.
Yes, yes.
So it is done. Anyone still having any query in this? No?
No, sir. No, sir.
So let's continue with the week 9. Yeah, you can ask your queries from activity questions. Let's try.
So is that answer transcripts are already released or not?
The answer transcript released or not released till now?
Yes, sir.
Not released means.
Yes, sir. It is not released on our course tab.
Okay, then you can check after that it gets released. So you can check for it. Okay.
Okay, sir.
So here is your
So there is a question in activity 1. Can you just scroll down, sir?
this 9.1.
Yes, sir.
Okay. So yeah,
Yes, sir. The sixth question, sir.
this one. Yeah.
Yeah, it's giving answer as 3, but I'm getting it as 4.
Okay. So first thing, let's focus here. So it is asking vector valued. Okay, means the range is going to be a range, or the codomain space has the dimension more than 1.
Yes,
So
sir.
I can eliminate my first option. It is in R. Okay.
Yes.
Next, I can eliminate nobody, or I can eliminate this one, this fourth one.
Yes, sir.
First and fourth are eliminated. Second, third, fifth, and sixth. 4 options are there. Next, it is saying multivariable. So you can see fifth is having only one variable in the domain space. So it will also be removed. So how many left? 3.
Okay. Got it, sir. Got it.
Yeah. Anyone else having any query in this 9.1? Basically, it is about this thing. So you have to understand 2 things. This one. You have 2 types of function. Let me take a page here. Okay. Let me. You have 2 types of things: scalar valued, and vector valued. Okay, and here you will have a single variable, and multivariable. So basically, scalar valued are those whose codomain space is in R. Okay, and vector valued are those, or I can say R1, one dimension. Okay, vector valued are those whose codomain space is in R M, where M is greater than 1. Okay. Next is variable. So if your domain is in R, then you can say single variable. And if your domain is in Rn, where n is greater than 1, so it is multivariable. That's all. Okay. Okay, I am presenting something else. So let's move on to the activity question. So in this question, if you look on the top, you can see what is the domain of f. So you can see two variables are there, so it will be in R2. Next, it is asking for range. So range is a single real number, it is not a vector, so you can say that it is in R. Okay. Next is this one. How do we define this product law? So product law is only defined when this Rm, when you are defining the range is in R1.
One.
Okay, so it is wrong. Addition is defined everywhere. Same, the scalar multiple it is defined, but you can see here c times when we are multiplying, it is getting 1 by c times. So it is wrong. It will get c times. So it is wrong. Next, m is 1, then also the division is defined. Means division and the multiplication. Yeah. Yes, Pallavi?
Sir, I'm asking like in the previous question, x square minus 2y is given. So if it is x square minus 2y square, then it will be R2. Range will be R2.
Sorry, if it was?
Sir, I'm asking, can you hear, am I audible?
Yeah, yeah, exactly.
Sir, I'm asking like if it is x square minus 2y square, then it
Okay.
will be, the range will be R2.
No, 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 not. It will not be R2. R2 means if there is one other component here, it means x square minus 2y, comma, x minus y like this.
Oh, okay,
It
sir.
is a
That means
vector.
one is there, that means R.
R. Exactly.
Oh, okay, sir.
Depend upon the component because we are working with vectors. So here we will have vectors and here we will have vectors.
So then if x comma y, there is two components, x comma y. That's why we are taking domain for R2.
Yeah, yeah, exactly.
Okay, sir.
Two components here. After that we have this, and then m is equal to 1 we are given as, so the division law also satisfies, means f by gx will be equal to fx by gx functions. Okay, means product and division function works when this m is 1 of codomain space dimension, and sum and difference function will run everywhere, and this scalar product will also run. Next is this one, which one of the following can be f? So it is asking domain is in R. Okay, means a single domain, single variable, it is single variable, and we have to find out which one can be f. So you can see here, the here function can't give two values at same point. It is giving two, so it is not. So it is a function, this is rational function, this is it is a logarithm function, and it is polynomial. Three functions we are having. Okay, just this is not because it is giving two values. If I put a x something like 10, suppose not 10, let's say 19. So what I will get, if I put 19 here, so 19 minus 10 will be 9, and square root of 9 will be 3. So 4 plus 3 and 4 minus 3, two values are there. So functions never give two values, they give only one. Okay, they can give two values when you define your, this is not in R, it is in R2. Then you can say that it is having two components. Okay, then in different components you can write 4 plus 3 in one and 4 minus 3 in other one. Then you can, it can work. Next is output of a scalar valued. Scalar valued multivariable means domain is multivariable, means it is going to have dimension more than that. So output it is asking to range. Range is scalar, so it will be a real number, right?
Yes.
Okay, but it can be complex number as well. Let me check this thing, because if complex number are allowed, then it can
So
cause.
in lectures we have not been taught complex thing. Only real thing has been taught.
Let me check this thing. Complex number. Yeah, that's fine. Complex number are not there, so that's okay. Real number you can use. Next is this one. Output of a vector valued multivariable can be a real number. So output of a vector valued. So vector valued means you will give more than one number or more than one real number you will have in output. So it cannot be a real number. It will be a vector. Vector valued it is. It will be vector.
Sir, but if m is specified
Yes.
to be 1, then it is possible, no?
When we only say vector valued when it is greater than 1.
Okay.
Okay. 1 is not in there, strictly greater than 1.
Oh,
Okay.
yeah, yes, sir. True.
So can you give an example, sir, in this case, please?
Okay. Entire screen will be there. Okay. So if you have a function, what was the question? Let me check that. So it is vector valued multivariable. So means I have to take more than one variable here. Suppose I am taking 2 and vector valued I have to give. So it will be suppose x plus y and x minus y. It is from R2 to R2.
Okay, okay, it's a vector valued. Okay, okay.
The vector valued it is. This codomain is differentiated by vector valued and scalar valued. Okay, and this domain space is distinguished by what do we say? Multivariable and single variable.
Sir, but if this is, say, for example, fx comma y is equal to x plus y, okay, in that case, it will become a scalar valued.
Yeah. If only one component is there, then it will be scalar.
Scalar valued.
But now it is vector. Okay, it is multi here. So in this case, it can't give a real number. It has to give a vector that is having real components. So it is false. Next is single variable value. Yeah, yes, Pallavi?
Means given
Sorry,
example for
for scalar
scale.
value. Okay,
So am I audible? Yes, sir, for
yeah,
scalar value.
scalar value. You can say xy is equal to f, sorry, not f. It will be x plus 2y, suppose. This is scalar value.
If a comma is
Where is the comma?
Sir, is
Yeah,
R2 to R2?
it is, no, it is from R2 to R. It cannot be to R2. Okay, it will always be in R1 if it is scalar valued. Means R1 it will always be, and it will always in R n, where n is greater than, or m, you can say m.
I'm asking if comma is added, then will it be scalar again?
Only comma is there, and other values if I here it will be given. Not only comma will be there. If any other value is given, then in this one question, I think you are considering this part, right?
Sir, if it is given x plus y comma 0, it would be a vector only, right?
X plus y comma 0. Yeah, it is vector now.
Vector.
It is vector. This is vector. Next is single variable vector valued. Means single variable we have to give, and vector valued is always a vector. Yes, single variable we need to give. Suppose f of x, and vector value I need to give output. So it will be x plus x only. Take suppose x and 3x and x 4x plus 5, 4x plus 5. So it is a vector valued, but single variable. So its output is vector. So it is okay, correct, this one. Next is vector valued multivariable cannot be a real number. Yeah, it cannot be a real number because it has to be a vector. How can it be a single real number? So this is correct. Okay. After this, it is where we have to consider a function st cos t tiny. Okay, this one. So we have to find out what kind of this one. You can see how many variables are here.
One variable.
One variable. So
One.
it is a single variable. So it
Yes.
is single variable. And here is it a vector or a single value?
Vector.
Vector, vector.
It is vector value single variable.
Like,
Okay. Yeah. Domain is going to be in R because one variable. So domain is R, and codomain is in R3 because it is a vector in with 3 components. Okay. So this is correct. After that, for this, I already gave that you have to find out vector valued and multivariable. So multivariable, out of these, you can see this is not multivariable and all others are multivariable. Many variables are there. Okay. And after that, you can see vector valued. So except this 5, we have to check how many are having vector value. This is not having vector value. Only single value is there. It is having vector value 1. It is having vector value 2. It is not having vector value. And it is having vector value 3. So three functions are there. Okay. Is that visible now? After that, you are given a G where you have to find a okay, it is a function from D to R3 and D is in R2. Okay, so we have to find out which may be G, which one can be G. So this is not G because you can see that its domain is in not in R2. So you can remove this third. So now we have to check first, second, fourth, and fifth. So next is the value should be in R3. It is not in R3. You can see it is the only R, a single real number. Okay. After that, it is in R3. So this is okay. This is in R2. So it cannot be. Okay. And this is in R3. So this is okay. Okay. Now here it is. You have to solve this. Okay. Tell me what is the domain of F in this case? What will be the domain?
R2.
X and Y.
In this one, you can see domain is not R because for complete R it is not defined. So domain will be restricted from
So
R2.
domain of F will
Yeah.
be the first one, na? X square by 9 plus y square by 6 less than equal to 1.
Less than equal to 1. Yeah, that's correct. Why it is? Because if you look at this
Then only it
function,
will be defined.
yeah,
Square root is not defined for negative values.
negative values. Okay, so that's why it has to be changed. You can see here. So if I look at this value, so what is it? Here we have 1 minus, I can say that x square by 9 plus y square by 9 square root. So I have this value under the square root. So if it is a square root, so it should be positive always. Okay, so if I remove the square root, I can say that it should be greater than 0. Okay, so if I add greater than or equal to 0. Okay, if I add both side this value x square plus y square by 9. So what I will get, 1 is greater than or equal to x
Sir,
square.
it is y square by 16, sir.
Okay, 16 it is. Okay, 16 by 9 by 16. So this is matching with this. So I mark this.
Got it.
Now can you, yeah, can anyone tell me the range?
So 0 to 1, sir. Close bracket, square bracket.
No, open bracket, no?
This
No,
one,
greater than equal to 0, right? So we can have 0 also, we can have 1 also, right?
yeah,
You
1
have
plus
to
0
choose
and 1
that,
minus.
that is 0 to 1, and then no square. 1 is not square bracket, 1 is square bracket.
square bracket you need to use. Why? Because
Then
this value, what?
if we consider 1 and this for range, then it will not be, it will become 0, no?
Okay, if you consider this equals 1.
Yes, so 0 will be
Yes, sir.
included. Correct.
Yeah, 0 will be included in that
Included,
case.
na?
Yes, yes.
Because x square by 9 plus y square by 9, you are having 16, you are having. Suppose x and y, x value you took 3 and y value you took 4. Not 4. 3 by root 2 and 4 by root 2. So it will be 1 and 1 minus 1, 0. So 0 will be included. And 1, you can put x equals 0 and y equals 0. So what you will get here, 1
0.
minus 0
1 minus 0.
will be 1.
True.
So this, is that clear?
Yes, sir.
After this, we have this function where R2 to R3 we have to define. It is defined. Okay, so function is given like this. So you can see R2 it is. So f is multivariable or single variable?
Multivariable.
Multivariable.
And PQR, you can see that it is from R2 to R3. So these three components are real numbers, right?
Yes.
So PXY is a real number. It is a real number. It is a real number. So now you have to tell me that this PQR are single variable or multivariable firstly.
Multivariable.
Multivariable. Okay.
Multivariable.
Vector valued or scalar valued?
Scalar.
Scalar valued.
After this, it is given. Okay. In this one, you have to consider a function. It is given okay like this, and an ellipse in the form of this. Okay. If ellipse is in the form of this, so this is an ellipse where a and b are the dimension of the ellipse. Okay. And ellipse is increasing in size if fxy is equal to c. Okay. C increases from 0 to 1, decreasing in size, where C increases from 0 to 1, okay, and constant in size, okay.
So basically, it's saying if x and y increases, what will happen to f of x? Like, f of x comma y.
It is saying that C increases from 0 to 1, okay, let me check this. So we are given the equation like this function 1 minus x square by 9 minus y square by 4, okay. And it is saying that if you have an equation ellipse in the form of this x square by a square or a only a square, right? A square plus y square by b square is equal to 1. Then a and b are its dimensions. So if we have equation like this, okay, if it is equal to c, then what I can say that it will be equal to c square, and it will be equal to 1 minus c square, and it will be equal to x square plus y square by 9 by 4. Okay, so this is this. So on increasing the value of c, you can see if I increase the value of c, so this value will be,
Small.
it will get small. Yeah, it will decrease. Okay. So if it is going to decrease, so whatever the value of x and y at that point, I have to increase this thing. So on increasing, it should, it is decreasing when c moves from 0 to 1 we are moving. Okay. So earlier it was 0, so it will be 1, and when I move it to 0, so its dimension will get smaller and smaller. So earlier if c value was 1, so it will be an equation of x square plus y square by 9, 4 is equal to 0. And if I put c value as 0, so it will be an equation of x square by 9 plus y square by 4 is equal to 1. So this is an equation, okay, and here, what would that be?
So x5 will be 0, 0, no?
What? In
So
this
on
case,
the LHS, both x and y
exactly,
will be
x is
0.
0 and y is 0. Yeah, it is only a point in this form. Point it. Okay, and in this form it is ellipse. So on it's going from 0 to 1 for the c value, here I took 1 and here I took c value 0. So from 1 to 0 when we are going, so it is increasing. Means these are inversely proportional. When I am increasing my c, so it is getting decreased. When I increase my c, so my d will, it will get decreased. Okay,
Yes, sir.
that was. Next is this one. In this one, you are given a point source 1, 2, 3, radiating energy. Intensity is given by P, okay, in space inversely related to the square of the distance, okay, between P and S and P. Okay, S, if you want to find out the intensity at point P, so it will be the distance, inverse of the distance of this one. Okay, it is given here. Intensity is given by K by D square. So you have to find out intensity is constant when x comma y comma z, and this is okay. Okay, so how do we find out the distance between P and S? So simply subtract x minus 1 square, y minus 2's whole square, and z minus 3's whole square. So it will be
Not
d
sure.
square, right?
Yes.
So here it is given x minus 1 square, y minus 2 square, and z minus 3 square is 1. So the intensity at that point will be k by 1. This is the distance square, right? Distance
Yes.
square value is given as 1. If distance square value is 1, so at that point, intensity will be k. So intensity is constant. Here also the intensity will be constant because distance is fixed here.
Yes.
So that's why these two options are correct. In these two, no, because there are other values x, y, y, z, so they are not constant, so they can move in that direction.
Basically, they are the length of the vector p.
Yeah, so it is done. Let's check which one I left. Okay, this one, where it was decreasing on going from this. Partial correct. Okay, it is also a point fx is equal to 1. If I put this value 1, so it will be a point, the same thing I discussed here. So if you put it equal to 1, so you got x square plus y square by 9 by 4 is equal to 1 minus 1. That is 0. So here you got this point. Okay. From activity 9.2, let's do. Okay, how do you calculate the rate of change? So rate of change is nothing but you have to calculate with respect to some direction, or it is partial derivative, you can say, with respect to z. You have to calculate. So differentiate this function with respect to z and put this value. Okay, you are given this function. Let's take this and paste it here. Okay. So if you want to calculate the derivative with respect to z, so differentiate it with respect to z. So on differentiating it, df by dz. So it will be equal to 6z minus 2y. Okay, now I will put the value 1, 2, minus 1. So g value is minus 1. So I will put 6 minus 1 minus 2. Y value is 2. So 2 here. So it
Yes,
will
sir.
be minus 6 minus 4. That is minus 10. Minus 10 it will be. Okay. Next it is saying that identify the correct options with respect to the partial derivative of f. So it is saying partial derivative with respect to x. So what will be the derivative with respect to x? It will be 3x square plus 3y. And what will be the partial derivative with respect to y? It is df by dx. Okay. And what will be df by dy? It will be equal to uh, it will be 0 and it will become 3x. Okay. So these two are equal. No, these two are not equal. So this option is wrong. At point 0 comma 0, if I put 0 comma 0 here, so it will be 0. And if I put 0 comma 0, 0. Yeah, this is correct. If I put 1 comma 1 both side, so here if I put 1 comma 1, so it will give me 3 plus 3, 6, and here it will give me 3. So this is also wrong. If I put 1 comma 0, x value 1 if I put here, so I will get 3, and if I put here 1, so I will get 3. So they are same, so this is correct. Next, dfx is dfy, sorry, df by dy plus 3. No, it is not. These two are not difference with 3. It was 3y. Then correct. Otherwise, it is wrong. So second and fourth are correct. Okay. Next one. In this one, you can see we have a function. Identify the correct option with respect to partial derivative of f. Partial derivative we need to consider here. So you can look here that this function is not defined at 0 comma 0. This function value is not defined. So if it is not defined here, so it is not continuous, and if not continuous, so not differentiable. Okay, you can leave this option that it is not defined, so you can say that it is not defined. Next, it is defined elsewhere. How do we find out that it is not defined as 0? Because if you put 0 comma 0 here, you can see that the value will be like, let me take the screenshot, put it here. Yeah. So here you can see, if I put value 0 comma 0 here, so 0 into 0 divided by 0 square plus 0. So in denominator we are having zeros, so that's why its value is not defined here. Next, we have to differentiate with respect to x. So if I differentiate it with respect to x, so what would that be? Suppose my u is xy and v is x square plus y. So I have to find out derivative of u by v. So it is actually u dash v minus b dash u by v square, I think. This is. So if I find out derivative with respect to x, so it will be firstly differentiating first function with respect to x. So it is y, then multiplying it by v, that is x square plus y. Okay, minus v dash means its dash, second function differentiation with respect to x. So it will be 2x and multiplied it by first function xy divided by v square. This is x square plus y whole square. Okay. Now if I find out it is df by dx, and if I find out df by dy, so what would that be? This function differentiation with respect to y, so it will be x, okay, times x square plus y. Next, this one, it will be equal to 1 times xy divided by x square plus y whole square. Is that clear? If I put 1 comma 1 here, so what I will get from my first equation, 1 1, so it will be 2 minus 2, so it will be 0. Here if I put 1 1, so it will be 1 1 plus 1 2, and minus 1, it will be equal to 1 by 1 square plus 1, so its whole square, it will be 4. So its value is 0 and its value is 1 by 4. So this is correct. This is wrong. 1 0 1 1 we have found. Okay, so 1 0 1 0 I need to check. So if I put 1 x value 1 and y value 0, so this term will become 0 and this term will also become 0 and it will be equal to 0. Here if I put 1 comma 0, so x value is 1, y value is 0, so it will be 1 minus 0 divided by 1.
1.
So it is okay. This is also correct. So let's check it once. Otherwise, okay. So this is correct. Next is this one. In this question, you can see R2 to R, we have defined a function like this. We have to find out derivative with respect to x and y, and their equality is given at 12 comma k. So what I can say that, take this from here to here, paste it. So I have x square plus 4x plus 4xy plus minus y square. So if I differentiate with respect to x, so it will become 2x plus 4y, right? And it is df by dx. Okay, and here if I do df by dy, so what I will get, 4x minus 2y. Okay,
Sir, minus y square, it will not be minus 2y.
sorry,
Means
where?
you are taking with respect to y, that's why.
Yeah, so it is minus 2y, it will be. We are
Okay.
doing differentiation of this function y square, we are with respect to y, so y square will be considered as minus 1.
When it will be dy, then it will be with respect to y.
Yeah, when we are doing
Okay.
with respect to x, so x function.
Okay.
So now if I put 12 comma k, so these two are equal. So if I put 12 comma k, x value as 12, so it will be 2 times 12 plus 4 times k. is equal to 4 times 12 minus 2 times k. Okay, so if I solve this, so it will be 24 plus 4k is equal to 48 minus 2k. So from here I got 6k equals 24 and k value is 4. Okay, k value is 4. This is 4. Okay, so let's move. Here we are given, suppose a function, this one is a multivariable function, yeah, and we have to find out f is a scalar valued. Is it or not? Tell me.
Yes.
Scalar value. Rate of change of function we need to find out at 0, 1, 1 with respect to x. Okay, so this function is there, so let's take it. So where it is, yeah. So if I find out rate of change of function with respect to x, so find out its derivative with respect to x, dfx by dx. So if I find out derivative with respect to x, so
Y
it will be y
0
plus 0
plus
plus
Z.
z, okay, minus 3y.
I think
This is
So if you put value 0, 1, 1 here, so what you will get? X value is 0, so x is not there, so no worry. You can put y and z value. 1 plus 1 minus 3 times 1 times 1. This is 2 minus 3, that is minus 1. So 1 is not, minus 1 it should be. So this is wrong. Next it is saying in the next option, sorry, in the next option, it is saying that rate of change of function at 2 to 2 with respect to x is same as rate of change of f with respect to z. X first time we are finding, and then z at this point 2 to 2 and 2. So with respect to x I found this, that it is a this function. So now find out with respect to z, df by dz or dz. Okay, so if I differentiate it with respect to z, so it will be 0, this one will be y, this one will be x minus 3xy. So I have to put 2 to 2 value. So if I put 2 to 2 here, so it will be equal to 2 plus 2 minus 3 times 2 into 2. Okay, so it is nothing but 4 minus 12. So that is minus 8. And if I put 2 to 2 here, so it will be 2 plus 2 minus 3 times 2 into 2. That is also minus 8.
same.
Both are same. So this third option is correct. Next is rate of change of function at 135 with respect to y. Y we need to find out. So now I will differentiate it with respect to y. So it will be x plus z, okay, minus 3xz. So 135 I need to find out, 135. Y is not there, so 1 and 5 I will put at x and z. So it will be 1 plus 5 minus 3 times 3 into 5. So that will be 6 minus 5, 3 is 15 and 45.
Yes, 11.
Sorry, it is 1. It is 1, not 3. X value is 1. So it is 15. That is minus 9. Okay. So it is minus 9. So it is also. Okay. Let's continue. And next is this one. We are given a multivariable function from R2 to R. So two functions are, sorry, their derivatives or partial derivatives are given with respect to x and y. So with respect to x it is this, and with respect to y it is this. So now we have to check which cannot be f. So what I will do, I will find out derivative with respect to x and then equate it with this, and then I find out derivatives with respect to y, and then I will equate it with this. So if they are equal, then this function can be, or this function cannot be. Okay, one thing you need to keep in mind, if derivatives are same, then it is not necessary that the functions are same. Suppose you have two functions. Your first function fx looks like uh, x square plus 5. Another function you have was derivative look, sorry, the function look like x square plus 9. So if you do the derivative now here, f of x by this, so it will be 2x, and here you can see it is also 2x. Derivatives are same, but not the functions. Okay, so same here, it is saying can be. It is not saying that it will be, it can be. Okay, so what I can say, 3x square, if I differentiate, okay, let me take this here to here. Okay, so if I do the derivative of this with respect to x, okay, x, so what it would be, 6x plus 4y 4 xy plus 3y. Okay, so is it matching with this? Yeah, now check it with y. Okay, so if I do it with y with respect to y, so it will be 2x square plus 3x minus 3 by 2 times 2y. So it is 2x square plus 3x minus 3y. So this is correct. Next one. Okay, in
Sir,
next
it
one.
is asking cannot be f, no sir.
Okay, cannot be, it is asking. So it is not. So if I do here, so what I will get,
So
6x
that negative will come.
plus 4xy minus 3y it will be. So minus 3y it cannot be, okay, because it is plus 3y. So
Yes.
this is correct actually, because it cannot be. Next is this one, 3x square minus 3xy. If I do the derivative, so 6x minus 3y, okay, minus 4xy plus 0. So you can see that it is not matching with this, so it is also okay. Next is this one, 3x square plus 3y square plus 3xy. So you can see that if I find out the derivative, so it will be 6x plus 0 plus 3y. So it is not matching with this, so it is also okay. So three options are correct, last three, first is not there. We have to find out which are not, okay, which cannot be f. Next is this one. Here we are given a function fxy from R2 to R2, means this p and q are scalar valued function, right? P is given like this and q is given like this. Now it is saying that we have to form a matrix in this way, that derivative of p by derivative of p with respect to x and derivative of p with respect to y, then derivative of q with respect to x and derivative of q with respect to y. So let's solve. Okay. So here it is, derivative of p with respect to x. So if I find out derivative of this, so with respect to x it will be
6xy.
dpy dx, it will be uh, 3 to the 6 xy. Okay, and if I find out derivative with respect to y, dpy dy, so it
3x
will be
square.
3x. Yeah, then 3 dq by dx, it will be
5
5, and dq by dy, it will be
3y.
equal to dy, right? So this is my matrix. It is saying a minus b I need to tell. So what is a? Determinant of a is this. If I find out the determinant of this, so it will be these two multiply. So it will be 18 xy cube minus 5 threes are 15x square. So it is saying that it is in this form, xy cube a times. So xy cube is there, a times means it is 18, like a value, minus bx square.
Sir, one thing is written wrong. 6xy uh, with respect to differentiating with respect to x.
X with respect to xi.
Okay, okay.
Okay. So here it is. I got a value as 18, b value as
15.
15 plus 15, because negative sign is already there. So only 15 I need to take. So a, that is 18, minus b, that is 15, it will be 3. Okay. If it is plus, then I will take b value as minus 15. Okay. But it is negative, so that's why negative sign is also compared. So it will be 3. After that, I am given this, that if determinant of a is 0, then find the value of xy. Okay. The same functions these are, right? No, the functions are also changed. So let's take a screenshot of this. So now I will find out again the derivatives. So dp by dx, it will be 6 dp by dy, it will be 2y, dq by dx, it will be 6x, dq by dy, it will be equal to 2. Okay. So if I find out the determinant, so it will be 12 minus 12xy, and it is given determinant is 0. So it is 0. So if I add 12xy both sides, so I will get 12xy equals 12, and I divide by 12 both sides, so I will get xy value equals 1. 1. Okay, it is 1. Next is this one. Here I am given a function from R2 to R. So this function is like this, and then I have to do, I have to find out this differentiation with respect to x and y, and then equate it with this. Okay, so let's go here, paste it over here. So this is my function. I have to find out derivative with respect to x. So here you can see that we have two functions here. First is e raised to the power 4x plus y. Okay, next function is v, that is sine of 7x minus 4y. So if I have to find out derivative of uv dash, so it will be u dash v minus v dash u. Means firstly find out first function derivative, then multiply second
The
minus,
product, no, sir.
yeah,
Plus,
product rule.
plus.
Sorry, yeah, plus product rule it will be. So if I find out derivative of this one with respect to x, so what I will get, e raised to the power 4x plus y, okay,
Into 4.
times 4. Okay, and then multiply by v, exactly same, sine 7x minus 4y. So okay, so after that v dash u. So if I do v dash this one, it's dash, so it will be equal to cos 7x minus 4y times
7.
7. Yeah, and multiplied by e raised to the power 4x plus y. This one. So it is saying that it is k times f of x, find the value of k. Here I am having cos function. Okay, 4 times, if okay, it is given that 4 times derivative with respect to x we did, and then I need to do with respect to y. So if I do the derivative with respect to y, so it will be same like this, x plus y sine x 7x minus 4y, right? And then plus 7 times cos of, sorry, minus 4 times cos of 7x minus 4y dot e raised to the power x plus y. So this is derivative with respect to x, and it is derivative with respect to y. So it is given, if I multiply it by 4 times this first function, 4 times this, and 7 times this. So what I will get? Suppose uh, suppose if I do, okay, so what I will get if I multiply it by 4 times, so I will get 16 e 4 x plus y sine, or I can say that this function, if you look at this part, it is same the previous function f. Okay, this part is previous function f. So what I can say, that it will be 16 f plus 4 multiplied to the 7, so it will be 28 cos 7x minus 4y, okay, times e 4x plus y. Okay, and then if I multiply 7 to this, so it will be
28.
28f plus, sorry, minus 28 cos 7x minus 4y dot e raised to the power 4x plus y. So if I add these two, so this term, the second term will get cancelled out and it will be equal to 16
44.
plus 28, 44 f. It is given as k times f it will be. So kf. So if I cancel this f, so I got k equals 44. Okay.
So where is minus 28 written? Like minus 4 was written, huh?
Yeah, minus 4 when we multiply this by 7. We have to multiply by 7. The derivative of f with respect to y. Okay. So it is 44. Let's check once. Yeah, it is 44. So okay. I think for today that's enough. Any other query you are having till now?
No, sir.
So that's enough for today.
Thank you, sir.
You're welcome, everybody. So
Thank
Thank
you.
you, sir.
you're welcome as well.
Thank you, sir. Good night.
Good night.